In the last video, I showed you how to create a list in Elixir, but now the question is, how do you operate on lists? For example, how do you actually add something to a list by prepending or appending items to the list? Let's take a look. I'll create a variable named counts, and I'll bind it to a list with three numbers, 5, 8, and 6. Now let's say we'd like to add the number 3 to the list. To prepend the 3 to the list we just created, I'll create a new variable named updated counts, then I'll key in the equal sign, followed by an opening square bracket, then I'll add the number 3. Next I'll use a new list operator, the pipe, which is called the cons operator, then I'll key in the variable named counts, followed by a closing square bracket. Now when I press enter, you see a new list that has the number 3 in the front, or again, what's called the head of the list. So do you think what we did on this line modified the original list? Let's check by keying the variable name counts and pressing enter. Nope, it hasn't been modified. It's exactly the same. So do you think there's anything we can do to modify the original list? Nope. You might recall from a previous video that all data in Elixir is immutable. Nothing can be changed. Let me ask you this. The list that the variable counts and updated counts point to are very similar in that each of them contains the common numbers 5, 8, and 6. Do you think each of these sets of numbers are stored separately in memory? For discussion's sake, let's say both of these lists are pointing to the same values in memory. This would be nice because it optimizes memory usage. Now, what if we could mutate data in Elixir, and we mutated the counts list, changing the number 5 to 50? Would this be problematic? Well, yeah, that would break the updated counts list. So if we could mutate data in Elixir, then these lists couldn't share values in memory. They'd have to be stored separately. However, since data can't be mutated in Elixir, why not share these common numbers between both lists? From a memory usage point of view, it's optimal. And you know what? That's exactly how Elixir and the Beam works. Essentially, what I'm saying is, because memory is immutable, there are certain optimizations that the Beam can make related to values stored in memory. Okay, but what if you really want to append the number 3 to the end of the counts list? It's possible, and to do this, we'll use the ++ list operator. The way this works is, we'll key the variable counts, which points to the original list, then we'll use the ++ operator, then, now what? Well, you might be tempted to just add a 3 to the end. Let's see if this works. Does that look right to you? What about this right here? That looks kind of weird, right? Okay, what we just did here was syntactically valid, but it didn't really do what we wanted. This right here is called an improper list, and generally speaking, you won't find yourself using these much. Actually, let me be a bit bolder and say you'll probably never use these. Okay, if you made a mistake like this and you're wondering what the correct way of appending an element to a list is, odds are you'd probably turn to Google to figure out what you did wrong, but you really don't necessarily need to turn to Google. Instead, we could use our helper function. For example, we could use the helper function on the ++ operator. Okay, let's try it. I'll key H, and this time I'll not use parentheses, because technically they're optional. Then I'll key the ++ operator, and I'll press enter. That didn't seem to work. IX is acting like I didn't enter a proper expression, and it's waiting for the rest of the expression, which is true. I did this on purpose. To back out of what I started here, I'll enter the following, $IX:break. This right here is a special break trigger that'll get us out of our halfway completed expression. Let me explain what's going on here. The helper function is expecting us to pass it either a module name or a function name. But in this case, we're trying to pass in an operator, the ++ operator. Okay, so was I misleading you earlier when I said you can use the helper function with the ++ operator? Nope, because operators, like the ++ operator, are just functions. A special kind of function, called an infix function. Now, most of us are probably used to using prefix functions, where the function name comes before the arguments. The difference between a prefix function and an infix function is that with infix functions, the function name goes between the arguments. Now, most operators we use in Elixir are actually in a module named the kernel module. Watch what happens when I start to key in kernel, and then I add a dot and I press tab. When I do that, we see a bunch of things we can use, like the plus and minus operators. And we can use these things, you see here, without even keying the kernel module name. All of these operators and functions and macros are automatically made available for you to use anywhere in Elixir. In other words, they're automatically imported, and you can think of them as globally scoped by default. Now, I just used the word macros, which is a new word that I haven't mentioned before. So you might be wondering, what exactly is a macro in Elixir? Well, I don't want to dive too much into macros just yet. For now, I just want you to be aware that Elixir has this thing called macros, and they're used extensively, and you're going to start seeing things that are called macros, and we're going to start using them quite a bit. You can think of macros as code that transforms other code. This isn't a comprehensive definition of macros, but it's a good, simple way to think about macros. A bit later in the course, we'll dig a bit deeper into macros. Now, back to this list of things we get from the kernel module. Near the top of this list is the plus plus operator right here. In an earlier video, I briefly pointed out these slashes, but I didn't tell you what they were. But I bet a lot of you have already guessed what it represents. It represents the number of arguments the function takes, which is called the function's arity. So in the case of the plus plus operator, it's an infix function that takes 2 arguments. Let's try and run the hhelper function again, but this time we'll pass in the plus plus /2, and as you can see, it worked. We see the docs for the plus plus operator. Cool. Now, we could read the docs from top to bottom, but sometimes the quickest way to figure something out is just to look at the examples. Notice with this example, the plus plus operator is being used on 2 lists, and it's returning a proper list, which is what we were trying to do earlier. Now, this example is close to what we actually did in error. We had a list on the left and a number on the right, and we got an improper list back, which isn't what we wanted. Okay, so as you can see in the examples, we should have wrapped the 3 in square brackets, so essentially we'd be concatenating a list with another list. There's also a minus minus operator, which allows us to remove elements from a list. So for example, if we wanted to remove the 5 from this list, we'd just enter counts minus minus and a list with a 5 in it. Or we could take counts minus minus a list with a 5 and a 6 in it. Whoa, what is that? You were probably expecting a list with just the number 8 in it. This probably seems pretty weird to you. It's actually a little oddity in IEX. When IEX sees a list and it prints it to the terminal, it tries to be helpful, in quotes. Remember when we looked at strings and I mentioned that Erlang deals with strings differently than Elixir? In particular, Erlang strings use a single quote, and they're actually called character lists. Well, under the covers, it's just a list of numbers corresponding to each of the character code points. So for example, watch what happens when I key in the following list. So here's what just happened. IEX tries to be helpful when printing lists, and what it does is it looks at each element of the list, and if every single element is a number that corresponds to a character, it thinks you're dealing with a character list, and so it prints it out as characters. So back on this line, what happened was the 8 corresponds to the backspace character, which you can see from the ASCII man page. So IEX just printed the character representation of the number 8. It's still just a list with the number 8. It's just presenting it in an unexpected way. Let's use the iHelper to find out more about the list type. Okay, well, most of what you see here you probably could have guessed. This term is a list data type, Well, yeah, we knew that. The reference module is the list module. Yeah, you probably could have guessed that as well. However, down here, under the implemented protocols, you see two things listed that we also saw with maps, which is the collectible and enumerable protocol. Now, I just want you to make a mental note of this, that lists implement these two protocols just like maps do. Eventually, we're going to start talking about protocols, and these two protocols are particularly important, especially the enumerable protocol, as you'll find out a bit later. Let's take a quick look at the functions that are available in the list module, and as you can see, there's quite a few of them. Okay, we've just barely scratched the surface on lists. There's a lot more we'll be covering throughout the course, so just be aware that the operators you've seen on lists and the functions you see here represent just a portion of the tools available for you to use on lists. There's much more to come. I want you to get some practice with lists, so I've created an exercise for you to get some hands-on experience. Now, you might be tempted to skip the exercises, but here's the thing. You can watch these videos and listen to me all day long, but if you don't practice what you see, it's not going to stick, and things will get really challenging for you when the pace of this course picks up in the near future. So don't sell yourself short. Take the few minutes required to complete these exercises. You'll see instructions on completing the exercise after this video. In the next video, we'll take a closer look at a data type you've seen a couple of times, but we really haven't talked about in detail, the tuple.